everyone, I'm going to go ahead and go over the examples for 3-4 day 2, just to help some people out in case they had some issues with figuring out matrices. So we're going to go ahead and take a look at working them out. If you are in first or second period, I did rearrange the order of the examples to help out a little bit, just as a heads up. So let's go ahead. So the first one we're going to take a look at is solve the system given. So we have a couple steps that we have. I can write the equations in standard form. I don't need to worry about that. It's taken care of for me, so that is done already. So we're just going to be like, check. Next is I can write the system as a matrix. So that is what we're going to actually start with. Step 1's not always done for you. Sometimes you have to manipulate things, but it is, so we're starting at step 2. So for a matrix, what we have here is it's another way to represent the system and not get bogged down with variables. So we're only actually going to have numbers in a matrix. So what we have here, in every row represents an equation. So in this case, we have 3 rows. And then for your columns, it's the number of variables plus 1. So in this case, it's 4. So we're going to have 4 columns. The first column is going to be the coefficients of x. The second column is going to be the coefficients of y. And the third column is going to be the coefficient of z. And the last column is what's after the equal sign. So what does the equation actually equal? If you have blank spaces like we do here, we have a blank space here, here, and here. Those are going to represent zeros. So when we write our matrix here for the x column, I have 0 in the first, 0 in the second, and -2 in the third. For the second column, for y, I have 0 in the first, 3 in the second, and 5 in the third. And then for column z, -2, 4, 5, and then the equals 6, -6, -9. So this is my matrix. It's another way for us to look at it and go ahead and work with it. As a heads up, if you just see a variable by itself or we have a negative variable, this one would get a 1 and this one would get a -1. So remember, if we see a variable, we have something there. It's when it's blank and not there that we would put a 0. So we're going to go ahead and take a look here at Desmos to use their matrix calculator. So I'm going to go ahead and bring that over. I'm going to go to Math Tools. I'm going to pick Matrix Calculator. To start off, we're going to create a new matrix. And we said we had 3 rows and 4 columns, so we need to adjust that so that we can fill in everything that we have. And then we're going to go ahead and copy the matrix over and write it exactly as we see it. So 0, 0, -2, 5, 3, 0, -2, 4, 5, -9, -6, and 6. And then you hit enter. You hit enter so that way you save it, and that way we also get back to the operation buttons for matrices here. So looking at this, my next step says I can write the matrix in reduced row echelon form. To get that, we're going to press the reduced row echelon form button, which is RREF. And you're going to say which matrix. So you can have 8 matrices here. We're going to use A because it says that this matrix is matrix A based on A equals. Oh, oops. So I'm going to type in A. I'm sorry, not A, but press A. And so we have it. So this is my reduced row echelon form. So now I'm going to go ahead and write that onto my PowerPoint. There we go. And we're going to do that in blue. So we did have 1, 0, 0, 0, 1, 0, 0, 0, 1, and 2, 2, -3. So this is my reduced row echelon matrix. So just as a heads up. So next we're going to identify the type of solution we have. So in this case, because we have the diagonal of ones, I know I have one solution. Because with the diagonal of ones and then everything else being a 0 in those first 3 columns, I know it's saying that x equals, y equals, and z equals is what this diagonal means. And so that ends up being that this row, this last column tells us our answer now. 2, 2, negative 3. So if I write my answer as a coordinate point, it would be 2, parentheses 2, comma, 2, comma, negative 3. And that's how I actually do systems with matrices. You could do this with 2 variables as well. You don't have to just only do it with 3. You can actually start it with 2 variables. Oh, oops, that was the wrong one. I copied that wrong. I'm sorry. So I'm going to head, actually that's not right. I copied the wrong matrix. I'm sorry about that. So I'm going to go in blue again. I'm sorry, this should have been no, it was right. Oops. I did have it right. I'm sorry. So we're just going to keep going. It was 2, 2, negative 3. We're going to head and move on to the next one. All right, so we're going to go to the next example. Order. That's what's throwing me off. All right, so on this we're analyzing what we have now. So based on what they gave us, my answer keys are in order. That's what's throwing me off right here. We're basically starting off at step 4. I can determine the solution based on what I have. So based on what we have here, that last column is going to tell me a lot of information that we have here. So if I read this is already in reduced echelon form. What this is saying is that x plus z equals negative 2, y plus 2z equals 8, and then that 0 equals 0. This last one here, when it's a true statement, that it's true that you have something 0 equals 0, 1 equals 1, 3 equals 3, that means we're going to have infinitely many solutions. And that means that one or both of the other variables are going to depend on the third variable to determine the value. So we're looking at this here. I can rewrite x plus z equals negative 2 as x equals negative 2 minus z. And we can rewrite y plus 2z equals 8 as y equals 8 minus 2z. So x and y depend on x to determine their value. So we would pick that z can be whatever we want it to be, but then I would have to use the formula negative 2 minus z for x and 8 minus 2z for y, and then but z is just whatever we want it to be. We are going to take a look at this next do, and that's just because it is a special case and it's the only one I have as the example. Looking at this last column, or row, I'm sorry, when we get 3 zeros and then a negative 6, so we get 0 equals negative 6, this is false. So we're going to get no solution. It is okay, however, to have a column that says 0 like this, because that just means z equals 0. Or I had 0. So if we had one that looked like this, that just means x, y, and z all equal 0. And that's fine because we still have that diagonal once. It's when that last row has 3 zeros and then a number. All right, for our next one, they give us the matrix, so we actually are done with step 1 and 2 already. And we're just going to go ahead and start at step 3. So we're going to rewrite this in reduced row echelon form. And using Desmos, we will get 1, 0, 3, and I'm going to go ahead and write the decimal version, negative 6.75. You could have also written negative 27 over 4. And then 0, 1, 5, negative 6. And then 0, 0, 0, 0. So this is my reduced row echelon form. So based on this last line here, again, I know that I have infinitely many solutions. Now, the next one, this is a little different than what we had earlier because they want you to actually give 2 coordinate points that live on this plane of where it exists. So what we're going to head and do is we can come up with our equations that we looked at last time. So I have x plus 3z equals negative 6.75. And I can go ahead and isolate x, and I get x equals negative 6.75 minus 3z. And for y, we're going to get y plus 5z equals negative 6. And when we isolate y, we get y equals negative 6 minus 5z. So when we do that, to find an actual coordinate point, I notice that, again, we can pick whatever we want for z. So if we were to write this as our coordinate point, it'd be negative 6.75 minus 3z, comma, negative 6 minus 5z, and then comma z. So when we look at this, I just have to pick a z value and then plug it in to find my x and y. So a good one to we always like using is z equals 0. And so you're just going to plug 0 in. If I plug 0 in, the z term goes away, and we're going to be left with x equals negative 6.75 and y equals negative 6. So we would plug that in. Another one, and I'm just going to do it in a different color because there's a lot of green there. We're going to do it in gray. If I chose z equals, I don't know, we can go with 2. You can pick whatever number you want other than 0 because we've already used it. For x, I would go ahead and substitute that in. So negative 6.75 minus 3 times 2. And that would get me negative 6.75 minus 6, which is negative 12.75. And then for y, we would use negative 6 minus 5 times 2, which is negative 6 minus 10, which is y equals negative 16. So for x, negative 12.75. For y, negative 16, and for z, 2. So that way it looks more like a negative 17 or negative 16. But that's how you would do an example of that one. And going to our last example, It's kind of just putting together what we've already did in the first one and throughout. We just go ahead and write our matrix given what we have. So based on what I see here in my first column, I would do 2, -1, -4. In my second column, I would do 1, -1, -3. In the third column, -1, -2, and -3. And then 1, 3, 5 in my last column. So that would be my matrix for this. We're going to go ahead and go with now our reduced row echelon form. So when we type this in the calculator, we would have gotten 1, 0, 0, 0, 1, 0, -3, 5, 0, and 4, -7, 5, 0. So with that, we have our reduced form. And so I'm going to take a look at this last row. Tells me I have infinite solutions. And in this case, they just want the equation of those solutions. So we have x plus -3z equals 4. So I can get x equals 4 plus 3z by adding 3z to both sides. And then y plus 5z equals -7. So if I subtract 5z from both sides, we get y equals -7 minus 5z. Then we're just going to go ahead and write our code. It depends on z, and we write our coordinate point, 4 plus 3z, comma, -7 minus 5z, comma, z. That was the last example. I am going to look at one other problem because all the examples we did do had z being dependent. So we're just going to take a look at the first DOL question from class. And it's already set up for you. It's in reduced row echelon form already. And by that, because we can see that the last one is all zeros, I know it's infinitely many. I just want to look at this one because it's different from what we've had earlier. That first row would tell me I have x plus 6y equals 1. The second row tells me z equals 6. And the last row says 0 equals 0. So this is one of those cases where it's not z. And I would choose to isolate to move 6y over so I don't have to have a fraction in my answer. So I would have x equals 1 minus 6y. So I would pick this one, and then it'd be 1 minus 6y, comma y, comma 6. If you wanted to solve to, and this depends more on Desmos than what your preference is. If they let you do a fraction, you can actually put it in terms of x. So if we had x plus 6y equals 1, I could rewrite this as 6y equals 1 minus x. Divide everything by 6. Generally, they don't like this, but you could do this if you really wanted to. So y equals 1 minus x all over 6 might be the easier way to do it. So x, 1 minus x over 6, and then 6. This, though, is the preferred because we prefer not to have fractions. But if you wanted to be fancy, yes, you could do that. So that is the class examples for this lesson, and hopefully this does help you. The Desmos calculator is going to be your best support on this in figuring out your matrices. But that is all I have for you, and I will see you in class next time. All right, bye.